Hello, everybody. I'm Salar Sohrabi, PhD student from University of Eastern Finland. So today I'm going to present my work, which is a comprehensive review about vitamin B12 and also its key drivers in aquatic ecosystems. Generally, vitamin B12 is crucial for at least 50% of phytoplankton species, serving as a cofactor in vital metabolic pathway. So only specific bacteria and also archaea can synthesize B12, making them essential for its availability. And many B12 dependent phytoplankton form mutualistic relationships with B12 producing bacteria, exchanging organic carbon for B12. So we can say also dynamic of B12 in aquatic ecosystem is largely unknown. So for this, we conducted a literature review from 1950 to 2022. Full texts were reviewed, so we collected the studies. We did title screening. Then we did also a full text assessment, finding ambient B12 data in their study. So we end up with 57 studies. From or gathering from studies, so most of the studies were carried out in oceanic, bay, lake, and also sea environment, as you can see here. And among all the studies, most were conducted in Atlantic and also Pacific Ocean, as you can see, as well as in freshwater ecosystems such as lake across different continents. As shown here, so most of the studies also focus on saline ecosystem with limited research on freshwater. So we are addressing this gap by studying boreal lakes in Finland. And next one is about the chart. It shows B12 research publication from 1950 to 2022. As you can see here, studies increased around 70s, 80s, but later declined as the findings were thought to be known. So bioassay was dominated in this period. After introduction of liquid chromatography, it revived interest by enabling of detection of B12 analogs, and so leading a rise to publication and more advanced studies in aquatic ecosystems. So we already also made a world map of surfaces of B12, as you can see here in various aquatic ecosystem. So our results indicate that highest surface dissolved B12 found in lakes and also coastal, and the lowest for open ocean. I already also brought a bar chart here with details that you can see. The main reason for a higher concentration in lakes and also coastal areas is likely due to closer proximity to land and providing more organic carbon and also cobalt needed for B12 production. And for climate effects, also B12 concentration are higher in subtropical and temperate zones than in polar and tropical regions, likely due to more nutrient and also organic carbon and cobalt from runoff, plus favorable condition for B12 producers, in contrast with high phytoplankton activity in tropical areas, which depletes dissolved B12. Also, seasonality affects surface dissolved B12 levels, as shown here. So B12 peaks in winter, likely due to low phytoplankton activity and reduced consumption. So as you can see here, we have vertical distribution of B12. So the dashed line shows particulate and also solid line shows dissolve. So as you can see, dissolved B12 increases with depth and specifically in mid and also deep waters, and depleted in the surface due to phytoplankton uptake. And for particulate, decreases with depth, so it has a reverse pattern. So peaks at the deep chlorophyll maximum, where phytoplankton biomass is highest. And for take-home message, we can say that ecosystem type influence B12 dynamics, and also terrestrial inputs play a crucial role in B12 production, also for producer. and vertical distribution and seasonality are dependent and complex. Thank you so much for your attention.